This question is about weak acids. Part A. Compound A is a weak monobasic acid. A student is supplied with 250 centimeters cubed solution prepared from 2.495 grams of A. The student titrates 25 centimeter cube samples of this solution with 0.084 moles per decimeter cubed of NaOH in the burette. The student carries out a trial followed by 3 further titrations. The diagrams show the initial burette readings and the final burette readings for the student's 3 further titrations. All burette readings are measured to the nearest 0.05 centimeters cubed. Part 1. Record the student's readings and the titers in an appropriate format. Calculate the mean titer that the student should use for analysing the results. The key piece of information in this question is that we need to write the titers in an appropriate format. So that's why I've drawn a table for any question like this, and it's quite common where they ask you to put something in a specific format. Tables are a really good idea. So if we add labels to this table, first heading could be titration 1, 2 and 3. Then we can have our initial reading in centimeters cubed, our final reading also in centimeters cubed, and then a titer that we need to work out in centimeters cubed. If we look at titration 1, the initial reading is 0.60. You read down on the burette. The final reading is 23.15, making the titer 22.55. For titration 2, the initial reading is 23.15. The final reading is 45.95, making the titer 22.80. Notice I'm writing everything to 2 decimal places, and this is a really important skill and technique to use when doing titration readings because you can get marked down if you don't. Titration 3, the initial reading is 10.00, 2 decimal places, and then the final reading is 32.45, making its titer 22.45. Next key piece of information is that we're looking for a mean titer. When working out a mean titer, you look for concordant results, and that is plus minus 0.10 centimeters cubed. So if we look at our titration titers, titration 1 and titration 3 have concordant titers. So when working out the mean, we do 22.55 plus 22.45 divided by 2, which gives us 22.50 as our mean titer. So for this question, you get 2 marks for drawing the table and having everything correct to the right number of decimal places, significant figures, etc. The mean titer has to be correct, that gets you another mark, and using the concordant results will get you your 4th mark. Part 2. The structure of compound A is shown below. Compound A has 4 optical isomers. Using this information and the student's results, answer the following. 1. Determine the molar mass of A and the formula of the alkyl group R. 2. Draw the structure of compound A and label any chiral carbon atoms with an asterisk. Show all your working. So here I've just taken some key pieces of information from part A. If I refer back, I can show you where I've got these. So I've taken the 250 centimeters cubed solution and the 2.495 grams of A, the fact that it was 25 centimeter cube samples that they used, and that it was 0.084 moles per decimeter cubed of NaOH in the burette. I've also rewritten the mean titer that we worked out, 22.5 centimeters cubed. So firstly, we need to work out the moles of compound A. We're going to use 2 equation triangles in this question. The first being Nigel's very clever, where we can work out number of moles, the second being mass over RFM times moles. And that will give us the molar mass of A, which is another way of saying RFM. So if we start by taking the concentration of NaOH, 0.084, and multiplying this by the mean titer of 22.5 times 10 to the negative 3, because we want it in decimeters cubed. Centimeters into decimeters cubed, you need to times the centimeters cubed by 10 to the negative 3, or divide by 1,000. That gives us 1.89 times 10 to the negative 3 moles of A in 25 centimeters cubed. So that means that it's 1.89 times 10 to the negative 2 moles of A in 250 centimeters cubed. So, secondly, we need to use our next equation triangle. That means taking the mass of A, 2.495, and dividing that by 1.89 times 10 to the negative 2 to give us a molar mass of A, or RFM, relative formula mass of A, at 131.7, which we can round to 132. This molar mass is the compound A plus its R group. So we can work out the relative formula mass or molar mass of the R group or alkyl group by subtracting the RFM of compound A that we can already identify. So if we look at how many carbons there are 2 carbons in the compound A that we've been given. So carbons 2. Then we look at our hydrogens. We've got 1, 2 in the OH groups and 1 coming off of this middle carbon, because each carbon has to have 4 groups attached, or 4 bonds, and this one doesn't yet, so it would have to have a hydrogen. The second one here, that has 2, like a double bond attached to the oxygen, so that has 4 bonds already. So that means we've got 3 hydrogens, and then for our oxygens we also have 3, and that's easy enough to identify because we've got 2 in the OH groups and 1 in our carbon R group. So we subtract the relative formula mass of our compound A, or partial compound A. That would be 12 times 2 to represent carbon, plus 3 to represent hydrogen, and plus 16 times 3 to represent the oxygen. That gives us 57 as our RFM of the R group, which means our R group must be C4H9. So if we redraw compound A to answer the next bit of the question, which is talking about chiral carbons. So here I've drawn our R group of C4H9, and we need to label any chiral carbon atoms with an asterisk. A chiral carbon is a carbon with 4 different groups attached. If we start on the right and we look at this carbon, well, we've got a double bond attached to the oxygen. Any carbon with a double bond cannot be a chiral carbon. So it's not this carbon. Moving along, and we look here, well, this carbon has 3 groups that we can see, but it would also have a hydrogen, which we've established over here. That would make this carbon a chiral carbon atom. Moving along, if we look at our next carbon atom here, well, this also would have a chiral center because we have 4 groups attached. We've got 3 that we can see plus a hydrogen. On the ends of the molecules here and here, they would be CH3 groups, and because, well, if we drew a CH3 group, we can see that we've got 3 hydrogens and an R group. Even though the R group's different, we've got 3 hydrogens, they're all the same, so it can't be chiral centers. Similarly here, we would have 2 hydrogens because it would look a bit like this, with 2 different R groups but 2 hydrogens, meaning this carbon also cannot be a chiral carbon atom. To get the 6 marks in this question, you need to work out the number of moles in 25 centimeters cubed, convert it to 250 centimeters cubed. You get your 3rd mark for working out the RFM or molar mass of A. You get your 4th mark for working out that it's 57, the molar mass of the R group. Working out that this is C4H9 gets you your 5th mark. Then drawing out compound A and labelling your chiral carbon atoms correctly gets you your 6th mark. Part B. The structural formula of compound A is repeated below. 2 reactions of compound A are carried out. Suggest an equation for each reaction and state the type of reaction. In your equations, draw structures of organic compounds and use R for the alkyl group. Part 1. Magnesium ribbon is added to a solution of compound A. Gas bubbles are seen and the magnesium slowly dissolves. So a key piece of information in this question is that we need to use R for the alkyl group. If we start by writing out our reactants, we have HOCHR, COOH plus magnesium, because we're reacting with magnesium ribbon, and that will produce a salt of HOCHR COO 2 Mg, and then we also have hydrogen. To balance the equation, we need to have a 2 in front of our reactant to balance the 2 that we use here in order to balance the charges, because magnesium has a 2+ charge, and because we're only losing 1 hydrogen each time, means that this anion is going to have a -1 charge. So we need 2 to balance the charges. The type of reaction is a redox reaction. To get the 3 marks for this question, you get 2 marks for the correct and balanced equation and 1 mark for stating redox. Part 2. Compound A is heated with a few drops of concentrated sulfuric acid as a catalyst. A cyclic dimer of compound A forms. The key words in this question are that we're forming a cyclic dimer. I've redrawn compound A above just to help us keep track of everything in this question. We start this question by writing our equation, so let's write out compound A as we've done in part 1. HOCHR COOH. We can write our sulfuric acid if we want over the arrow. This we're going to form because we've got a carboxylic acid and an alcohol. If I label those groups, we've got carboxylic acid here. So carboxylic acid I'll just write as Ca, and an alcohol. So alcohol there. That's going to form an ester group. So if we're having a dimer, and a dimer means that it's 2 identical groups attached, it's going to look a bit like this with our partial A attached either side. I will identify the ester links in just a minute. So if I'm showing the ester links, here is one ester link and here is our second. And we can see that this molecule is symmetrical, which is what a dimer is. 2 identical groups, very easy to split it down the middle and make it symmetrical. As we're forming an ester, this is a condensation reaction, so we would form water as a byproduct. The type of reaction we can say is esterification because we are forming an ester. To get the 3 marks for this question, we haven't actually finished. We need to balance the equation by writing a 2 here to get our 2 H2O molecules. So again, getting our 3 marks, you get a mark for your basic equation, a mark for getting all of the compounds correct, mark for balancing it, and a mark for naming the type of reaction and that being correct. C. Chromium 3 piclinate shown below is a neutral complex that can be prepared from the weak acid piclonic acid. Chromium 3 piclinate is used in tablets as a nutritional supplement for chromium. Part 1. Draw the structure of the ligand in chromium 3 piclinate. The key word in this question is that we're drawing the structure of a ligand. A ligand is in your transition element or metal topic, and we can identify the ligands because they are attached to your metal ion. We have 3 ligands and they are all identical. So it's one ligand replicated 3 times. Here I'm just representing them, and that means because they're all the same, we can very easily draw the structure. If we look at the diagram, they're going to look a bit like this. If we draw it at a different orientation, with making sure that we have our N attached, that our double bonds are in the right place, and that we have the rest of the molecule correct. We would then have a negative charge on our oxygen because the chromium would be having a positive charge and the ligand has to have a negative charge in that case. To get the mark for this part of the question, you need to make sure that you've drawn the structure of your ligand completely correct, and that will get you the mark. In part 2, we're told that a typical tablet of chromium 3 piclinate contains 200 micrograms of chromium. Calculate the mass in grams of chromium 3 piclinate in a typical tablet. 1 microgram is 10 to the negative 6 grams. Give your answer to 3 significant figures. To start, let's identify the key pieces of information we've been given in part 2. Our first key piece of information is 200 micrograms of chromium. We're also given the scale to use when converting micrograms into grams, and the fact that we need to give our answer to 3 significant figures. If we start by working out the relative formula mass of a ligand, we can then work out the relative formula mass of the whole neutral complex. So, to begin, if we look at one ligand here, we can identify how many carbon atoms there are and write a little list. So, let's count them. 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms. Then, looking at hydrogens, we can draw them as little sticks. So 1, 2, 3, 4. There are 4. Next, moving on to the number of oxygens there are. Well, this is slightly easier to identify. We have 1, 2 oxygens, writing that in our list, 2. And then finally, how many nitrogens? Well, we've got 1 there in our complex. So nitrogens, 1. Working out the relative formula mass, that gets us 6 times 12 plus 4 plus 16 times 2 plus 14, which gives us 122 as the relative formula mass of one ligand. There are 3 ligands in this complex, so we do 122 multiplied by 3, and then we need to add the relative formula mass of chromium, and that is 52. That gives us a relative formula mass of 418 for the whole complex. Next, we need to take the 200 micrograms of chromium, and we need to work out the number of moles using this. So we take 200 we multiply by 10 to the negative 6, and we divide by 52, because we're told that it's the mass of chromium, and 52 is the relative formula mass of chromium. That gives us 3.85 times 10 to the negative 6 moles. And we can then take the 418 and multiply by 3.85 times 10 to the negative 6. And that gives us 1.61 times 10 to the negative 3 moles, if we were to write our answer to 3 significant figures, which is what the question is asking. So 1.61 times 10 to the negative 3. The equation triangle that I have used to answer number 2 is as follows: mass over relative formula mass multiplied by moles. The way a equation triangle works is you cover up the item you're trying to work out, and what's left is the equation you will use. This question, in order to get our 2 marks, we first need to work out the relative formula mass of the complex, work out our moles. That together gets us our first mark, and then we multiply these to get our moles. Writing that to the right number of significant figures gets you your second mark.